Most Azure professionals are learning the wrong skill right now. They're chasing certifications in services that become obsolete every 18 months. They're memorizing the Azure portal. They're building expertise in specific workloads, AKS, functions, Synapse, as if mastery of individual services is what the market actually rewards. It's not. The real market value in 2026 isn't in knowing Azure. It's in preventing Azure from destroying itself. High-income cloud roles aren't filled by people who can provision resources. They're filled by people who prevent the wrong resources from being provisioned in the first place. The skill that compounds, the one that gets more valuable every year instead of less, is the ability to architect governance frameworks that scale, to design systems that don't erode, to codify intent in a way that makes human oversight unnecessary because the architecture itself enforces what should happen. This is what separates the six-figure architects from the mid-level engineers who are still clicking buttons in the portal. This episode explains why. The fundamental misunderstanding: why most Azure architects are already obsolete. Organizations treat Azure like a service catalog. You need compute, you pick a VM size. You need storage, you pick a tier. You need networking, you configure a subnet. It's transactional, it's reactive, it's completely wrong. What they're actually operating is a distributed decision engine. Every policy exception, every manual override, every just this once decision converts deterministic security into probabilistic chaos. Most Azure architects don't understand this distinction, and that's why they're already obsolete. The gap between knowing Azure services and architecting systems that don't erode is widening faster than most professionals realize. It's not a small gap anymore. It's a chasm. On one side are the people who understand how to use Azure. On the other side are the people who understand how to prevent Azure from being misused at scale. The second group makes significantly more money. They also keep their jobs when things go wrong. Here's why this matters. When you operate at scale, when you have hundreds of subscriptions, thousands of resources, dozens of teams all provisioning infrastructure simultaneously, human oversight becomes mathematically impossible. You cannot manually review every deployment. You cannot audit every permission assignment. You cannot catch every configuration drift before it becomes a security incident. The only way to maintain control is through architecture, through policy, through code that enforces what should happen before humans ever have the chance to make a mistake. The certifications teach you what Azure can do. They teach you the feature set. They teach you the capabilities. What they don't teach you, what they fundamentally cannot teach you, is what Azure should do given your constraints, given your risk tolerance, given your regulatory requirements, given your organizational culture. That's the skill that matters. That's the skill that's scarce. That's the skill that compounds. Most Azure architects are already obsolete because they're still thinking like infrastructure engineers. They're still thinking in terms of resources and configurations. They're not thinking in terms of control planes. They're not thinking in terms of erosion. They're not thinking in terms of how to make the system enforce its own rules without human intervention. The uncomfortable truth is this: if your governance depends on humans to enforce it, it's already failing. Somewhere right now, someone is bypassing your policies because they're in a hurry. Someone is creating a resource that violates your tagging standards because they forgot. Someone is assigning permissions that are too broad because the alternative would require a conversation with security. These aren't failures of individual judgment. These are failures of architecture. And if your architecture depends on perfect human behavior, your architecture is broken. The high-income roles in 2026 aren't filled by people who understand every Azure service. They're filled by people who understand how to design systems that make it impossible to do the wrong thing. People who can look at an organization's chaos and see where the control plane is breaking down. People who can codify governance in a way that scales to hundreds of teams without requiring a governance team to manually review every decision. That skill is rare. That skill is valuable. That skill is what this episode is about. What cloud erosion actually means. Cloud erosion is the inevitable drift between intended state and actual state as organizations scale. It's not a bug, it's not a failure of specific people or teams, it's a mathematical inevitability. And if you don't architect against it, it will destroy your infrastructure from the inside out. Here's what erosion looks like in practice. You define a policy that says all storage accounts must have encryption enabled. For the first month, it's true. Every storage account has encryption. Then a team needs to move fast on a project. They create a storage account without encryption because the alternative would require waiting for approval. They're planning to enable it later. They never do. Now your policy is violated, but it's just one storage account. It's not a big deal. Except it is, because now there's precedent. Now the next team that needs to move fast knows it's possible to bypass the policy. And they do. And the next team does. Within 6 months, 30% of your storage accounts don't have encryption. Your policy still exists. It's still in audit mode. It's still being violated constantly. But nobody's paying attention anymore because the violations are so common that they've become invisible. That's erosion. It's not a dramatic failure. It's a slow drift where the gap between what you intended and what actually exists grows wider every single day until one day you run a compliance audit and realize you have no idea what your actual security posture is. The distinction that matters is this: governance that depends on humans to enforce it is already failing. Not eventually. Right now, somewhere in your organization, someone is bypassing a policy because they're in a hurry. Somewhere a permission is too broad because nobody reviewed it carefully. Somewhere a resource is misconfigured because the person who created it didn't understand the requirement. These aren't failures of individual competence. They're failures of architecture. Cloud erosion has three primary drivers. The first is velocity. Teams move faster than policy can adapt. You create a policy, and by the time it's fully deployed, the business has already moved on to the next problem. The second driver is complexity. More services create more decision points. More decision points create more opportunities for drift. The third driver is incentive misalignment. Builders are rewarded for speed. Security is rewarded for compliance. Finance is rewarded for cost optimization. When these incentives conflict, and they always do, people optimize for what they're measured on, not for what's best for the system as a whole. Now add AI to this equation. Autonomous agents make decisions at machine speed. They can make thousands of decisions per second. If those decisions aren't pre-constrained by architecture, failures propagate exponentially faster than humans can detect them. A single misconfigured agent with overprivileged identity permissions can exfiltrate data, modify systems, or trigger cost explosions faster than any human can notice something's wrong. By the time you realize the agent is behaving badly, the damage is done. The uncomfortable truth is this. Most Azure environments are already in advanced erosion. They just don't know it yet. You can measure it. Policy compliance rates below 85% indicate erosion. RBAC assignments that can't be audited indicate erosion. Cost forecasts that diverge from actuals by more than 15% indicate erosion. When you see these signals, what you're actually seeing is the gap between intended state and actual state. You're seeing the architecture failing to enforce what should happen. The organizations that understand this are the ones that are winning in 2026. They're not trying to prevent erosion through better training or stricter reviews. They're designing systems where erosion is architecturally impossible, where the system itself enforces what should happen, where human oversight becomes a safety net instead of the primary control mechanism. That's the shift. That's what separates the six-figure architects from everyone else. The ability to look at an organization's chaos and see where the control plane is breaking down. The ability to design systems that don't erode because they can't erode. The ability to codify governance in a way that makes human failure irrelevant because the architecture itself prevents it. The three layers of architectural control. There are three layers where governance actually happens in Azure. Understanding these layers is the difference between architects who prevent erosion and architects who react to it after the damage is done. Layer 1 is identity and access. This is Entra ID. This is where you decide who can do what. And this is where most organizations fail catastrophically because they treat identity as a user problem instead of a system problem. They think about humans logging in. They don't think about the fact that non-human identities now outnumber human identities in most enterprises. Service principles, managed identities, AI agents, these aren't people. They don't need passwords. They don't need MFA. They need least privilege by default. They need just-in-time elevation. They need immutable audit trails that record every single action they take. Here's the architecture that works at this layer. Every non-human identity gets a distinct service principle. Every service principle gets scoped permissions, not broad roles, but specific permissions for specific resources. Every elevated operation requires explicit justification and approval. Every action gets logged in a way that cannot be modified after the fact. This is the first control plane. If identity is compromised, all downstream controls fail. So this layer has to be airtight. Layer 2 is policy and compliance. This is Azure policy. This is where you prevent bad decisions from reaching infrastructure in the first place. Most organizations use Azure policy in audit mode. They deploy a policy that says all storage accounts must have encryption enabled and set it to audit. The policy fires, it logs violations, it creates visibility, but it doesn't actually stop anyone from creating unencrypted storage accounts. That's not governance, that's theater. Real governance happens in deny mode. A policy in deny mode says you cannot create this resource because it violates our requirements. The deployment fails. The resource never gets created. The person who tried to create it learns immediately that this isn't allowed. This is where the architecture actually enforces what should happen. But here's the hard part. Deny mode policies break things. They break workflows. They slow down teams. So most organizations are afraid to use them. They stay in audit mode forever, watching violations accumulate, telling themselves they'll tighten it up later. They never do. The scaling problem at this layer is that policy exceptions accumulate faster than policy rules. Every exception is governance debt. Every exception is a signal that your policy isn't quite right. But instead of fixing the policy, teams just add exceptions. This team needs to create unencrypted storage accounts for testing purposes. So you add an exemption, then another team needs the same exemption, then another. Within a year, your exemption list is longer than your policy list. Your framework becomes unmaintainable. Layer 3 is operational enforcement. This is CI/CD gates. This is cost controls. This is drift detection. This is the systems that catch what the other two layers miss. Governance that isn't automated is governance that isn't enforced. Cost controls that depend on manual review are cost controls that fail at scale. Drift detection The practice of continuously comparing actual state to intended state and flagging divergence is the only way to catch the erosion that happens between deployments. The hardest part of this layer is that it requires discipline across teams. It requires discipline in your CI/CD pipelines. It requires discipline in how you define intended state. It requires discipline in how you respond when drift is detected. Discipline is expensive. Discipline is uncomfortable. But discipline is the only thing that prevents erosion at scale. These three layers work together. Identity prevents unauthorized access. Policy prevents bad configurations from being deployed. Operational enforcement catches what slips through the cracks. None of them work in isolation. All three have to be in place, all three have to be enforced, and all three have to be continuously monitored and adjusted as the organization changes. This is what separates the architects who prevent erosion from the architects who react to it. The ones who understand that governance isn't a single control, it's a system of controls working together, each one compensating for the limitations of the others, each one enforcing what should happen at a different point in the infrastructure lifecycle. Why AI amplifies every governance mistake. AI agents operate at machine speed. They can make thousands of decisions per second. If those decisions aren't pre-constrained by architecture, failures propagate exponentially. This is the critical insight that most organizations haven't internalized yet. They're deploying AI agents into environments with governance frameworks designed for humans. And those frameworks are about to break under the weight of machine speed decision-making. Here's the distinction that matters. Traditional infrastructure is deterministic. If you provision a virtual machine with a specific configuration, you get that configuration. The outcome is predictable. You can reason about it. You can audit it. But AI introduces probabilistic layers. If you ask an agent to do something, it might do it one way, or it might do it another way, or it might do something slightly different that you didn't anticipate. The agent isn't malicious. It's just operating probabilistically instead of deterministically. And if that probabilistic behavior isn't constrained by architecture, it becomes chaos at scale. Most organizations still share human credentials with AI agents because they don't have formal agent identity frameworks. Think about what that means. An AI agent is using the same identity as a human employee. The audit trail doesn't distinguish between actions taken by the human and actions taken by the agent. If the agent does something wrong, you can't tell who's responsible. If the agent gets compromised, the attacker has access to everything the human has access to. This isn't a governance framework. This is a security disaster waiting to happen. Entra Agent ID is Microsoft's answer to this problem. It gives AI agents distinct identities with scoped permissions, audit trails, and lifecycle management. But most organizations haven't implemented it yet. They're still in the credential sharing phase, which means they're running their infrastructure on shared credentials and hoping nobody notices. Here's the real cost of this approach. An AI agent with overprivileged identity permissions can exfiltrate data, modify systems, or trigger cost explosions faster than any human can detect it. A single misconfigured agent can generate thousands of dollars in unexpected compute costs in minutes, not through malice, not through compromise, just through the normal operation of an agent that's been given too much permission and is operating at machine speed. The cost amplification problem is particularly acute with retry loops. An agent retries a failed operation automatically. If that retry isn't bounded, a single misconfigured agent can generate exponential costs. The agent tries to execute something, it fails. It retries, it fails again, it retries again. Within minutes, you've got thousands of retry attempts, each one consuming resources, each one accumulating costs. By the time you notice something's wrong, the damage is done. The governance patterns that work at this layer are pre-execution gates that validate agent decisions before they're allowed to execute. Cost estimators that block operations exceeding thresholds. Immutable logs that record every agent action. These aren't optional, these aren't nice to have, these are architectural requirements for running AI agents safely at scale. The uncomfortable truth is this. Most organizations don't have formal agent identity governance yet. They're running their AI infrastructure on shared credentials, which means they're operating in a state where a single misconfigured agent or compromised credential can cause exponential damage. They're deploying AI into governance frameworks that were designed for humans, not machines. And those frameworks are about to fail under the weight of machine speed decision-making. The organizations that understand this, that are building agent identity frameworks now, that are implementing pre-execution gates, that are treating agent governance as a first-class architectural concern, those organizations are going to win in 2026. Everyone else is going to have incidents they don't understand and costs they can't explain. The shift from ClickOps to governance as code. ClickOps is what most Azure environments are built on right now. You open the Azure portal, you click through the UI, you configure resources one at a time, you create policies by hand, you assign permissions through the console. It works at small scale. It works when you have 5 subscriptions and 1 team. It fails catastrophically at enterprise scale. Every click is a decision point. Every decision made through the portal isn't auditable, isn't reproducible, and isn't scalable. You can't version it. You can't review it through a pull request. You can't test it before it goes to production. You can't roll it back if something goes wrong. You just have a resource in a certain state, and if you want to know why it's in that state, you have to ask the person who clicked the buttons. If that person left the company 6 months ago, you're out of luck. Infrastructure as code solves part of this problem. You define your infrastructure in code, Bicep, Terraform, ARM templates, and you version that code. You can review changes. You can track history. You can reproduce the exact same infrastructure in a different environment. You can roll back if something breaks. This is a massive improvement over ClickOps. Most serious organizations have moved to ISC by now, but ISC solves the reproducibility problem. It doesn't solve the governance problem. Here's the distinction. You can write IAC that violates your policies. You can write Bicep code that creates an unencrypted storage account. You can write Terraform that assigns overly broad permissions. The code is reproducible and auditable, but it's still wrong. IAC doesn't prevent you from making bad decisions. It just makes those bad decisions repeatable and auditable, which is actually worse because now you've codified the mistake. Governance as code is the next evolution. You codify your governance rules and enforce them in your CI/CD pipelines. You define policies in code, you version them in Git, you test them in pre-production, you enforce them in production. Governance becomes as repeatable, auditable, and scalable as infrastructure. Here's what the workflow looks like. A developer writes Bicep code that creates a new resource. They push it to a Git repository. A CI/CD pipeline runs. The pipeline validates the code against your governance policies. The policy check either passes or fails. If it passes, the code can be deployed. If it fails, the deployment is blocked. The developer sees the error, understands why their code violated the policy, and fixes it. They push the corrected code. The pipeline runs again. This time it passes. The code is deployed. This is where the magic happens. The governance is enforced before the code reaches production. The developer learns immediately that their approach violates the policy. They fix it right away instead of 6 months later when an audit discovers the problem. The policy is applied consistently to every deployment. There are no exceptions. There are no manual reviews. There are no workarounds. The system enforces what should happen. The mental model shift is this. Instead of asking, can we do this? Ask, should we do this? And what would prevent someone from doing this wrong? You're not trying to enable every possible use case. You're trying to prevent every possible mistake. You're designing the system so that doing the right thing is the path of least resistance and doing the wrong thing is architecturally impossible. Why does this skill compound in value? Because once you've designed a governance framework that works, you can apply it to new services, new teams, new regions without starting over. You don't have to reinvent the wheel every time you onboard a new business unit. You don't have to manually review every deployment. You don't have to hope that people remember the policies. The system enforces them automatically. This is the shift happening right now in the market. Organizations are moving from ClickOps to ISC to governance as code. The people who understand this progression, who can design governance frameworks that scale, those people are the ones who are valuable in 2026. Everyone else is still clicking buttons in the portal, wondering why their infrastructure keeps drifting and their compliance audits keep failing. Landing zones as governance blueprints. A landing zone is a pre-configured Azure environment that embeds governance from the start. It's not a resource group, it's not a subscription, it's a complete opinionated blueprint for how an organization should operate in Azure. And it's the difference between teams that inherit chaos and teams that inherit order. The Cloud Adoption Framework provides a reference architecture for landing zones. But what matters isn't the specific architecture. What matters is the philosophy. A landing zone says, before you provision your first resource, before you deploy your first application, before you make your first decision about how to operate in Azure, here's how we've decided things should work. Here are the policies that will be enforced. Here are the management groups that will organize your subscriptions. Here's the network baseline. Here's the identity baseline. Here's how we're going to monitor and audit everything you do. Why does this matter? Because it prevents the blank canvas problem. If you give a team a blank Azure subscription and say, go build, they will build. They'll make 1,000 small decisions about how to organize resources, how to name things, how to configure networking, how to assign permissions. Most of those decisions will be locally optimal but globally suboptimal. They'll make sense for that team's immediate needs but create problems for everyone else downstream. By the time you realize the decisions were wrong, the infrastructure is too entrenched to change. A landing zone prevents this by establishing constraints before anyone starts building. The management group hierarchy is already defined. The policies are already deployed. The network baselines are already in place. The identity baselines are already configured. Teams don't have to make those decisions. They inherit them. And because those decisions were made by architects who understood the full scope of the organization's requirements, they're usually better than the decisions the team would have made on their own. The architecture of a landing zone includes several critical components. The management group hierarchy organizes subscriptions by function, environment, and compliance level. Azure policy assignments enforce tagging, encryption, network configuration, and RBAC at scale. Network baselines define virtual networks, firewalls, and private endpoints. Identity baselines define managed identities, role assignments, and conditional access policies. Monitoring and compliance infrastructure provides logging, alerts, and audit trails. Here's the distinction that matters. A landing zone isn't just infrastructure. It's codified intent about how your organization wants to operate at scale. It's saying, we've thought about security, we've thought about compliance, we've thought about cost management, and here's how we've decided to handle all of these concerns. Teams don't have to reinvent the wheel. They inherit the decisions that architects made, tested, and refined. Why does this prevent erosion? Because teams provisioning resources within a landing zone are constrained by policies they didn't write. That's the point. Those constraints prevent drift. They prevent teams from making locally optimal decisions that create globally suboptimal outcomes. They prevent the slow accumulation of exceptions and workarounds that characterizes eroded environments. The scaling pattern is elegant. Once you've built one landing zone, you can replicate it across teams, regions, and business units without reinventing governance. You're not creating governance from scratch for each new team. You're instantiating a template that's already been tested and proven. This is where the skill compounds. The first landing zone takes weeks to design and deploy. The second one takes days. The third one takes hours. By the time you've deployed your 10th landing zone, you've got a repeatable process that works. The common mistakes are instructive. Landing zones that are too permissive don't prevent erosion. They just push the problem downstream. Landing zones that are too rigid slow down legitimate innovation. The sweet spot is landing zones that are permissive enough to enable business velocity, but constrained enough to prevent erosion. That's the hard part. That's the part that requires architects who understand both the technical constraints and the organizational culture. This is what separates the organizations that scale successfully from the ones that don't. The ones that have landing zones that work scale faster and with fewer incidents. The ones that don't have landing zones are constantly fighting fires, constantly discovering misconfigurations, constantly dealing with the accumulated debt of ad hoc decisions made under time pressure. Azure Policy as the enforcement engine. Azure Policy is the service that enforces your governance rules at scale. It's not optional. It's not a nice to have. If you're operating Azure without Azure Policy, you're operating without governance. You're just hoping people make the right decisions. And they won't. Here's how it works. You define a policy. The policy is a JSON file that describes a rule. The rule might say, all storage accounts must have encryption enabled, or all virtual machines must have a specific tag, or all resources must be deployed to approved regions. You store this policy definition in code, you version it, you review it, then you assign it to a scope, a subscription, a resource group, or a management group. Once assigned, the policy applies to every resource within that scope. The distinction between policy definitions and policy assignments matters. Definitions are the rules. Assignments apply those rules to scopes. You might have a definition that says require encryption, but that definition doesn't do anything until you assign it to a scope. Once assigned, it applies everywhere within that scope. This is how you enforce governance at scale without creating a separate rule for every subscription or every resource group. The effects are where the real power lives. Audit mode logs violations without blocking them. This is useful for detection. You deploy a policy in audit mode. You watch it fire. You see what violations exist. You understand the scope of the problem. But audit mode doesn't actually prevent anything. It's visibility, not control. Most organizations stay in audit mode forever because deny mode is uncomfortable. Deny mode blocks violations from reaching infrastructure. A deployment fails if it violates the policy. The resource never gets created. This is actual control. But deny mode breaks things. It breaks workflows. It slows down teams. So most organizations are afraid to use it. They stay in audit mode, watching violations accumulate, telling themselves they'll tighten it up later. They never do. Deploy if not exists is the pattern that scales. This effect automatically remediates violations. If a resource is missing a required tag, the policy adds it. If encryption isn't enabled, the policy enables it. If a resource is created in an unapproved region, the policy moves it. This is where governance becomes invisible. Teams don't have to think about compliance. The system enforces it automatically. Why policy as code matters is this. Policy definitions are JSON files stored in Git. They're versioned, they're reviewed through pull requests. They're tested before deployment. This is fundamentally different from policies created through the Azure portal and stored nowhere. Code-based policies are auditable, repeatable, and scalable. Here's the workflow that prevents erosion. You write policy definitions in code. You test them in pre-production against your actual resources. You identify false positives and false negatives. You refine the policy. You deploy it in audit mode first to understand the impact. You gradually shift to deny mode as confidence increases. You monitor compliance metrics and adjust policies as the organization changes. The scaling problem is that policy exceptions accumulate faster than policy rules. Every exception is governance debt. Every exception is a signal that your policy isn't quite right. But instead of fixing the policy, teams just add exceptions. Before long, your exemption list is longer than your policy list. Your framework becomes unmaintainable. High-income architects design frameworks where exceptions are rare, documented, and time-bound. Here's a real scenario that illustrates the pattern. You create a policy that requires all storage accounts to have encryption enabled. Audit mode identifies non-compliant storage accounts. Deny mode prevents creation of non-compliant storage accounts. Deploy if not exists automatically enables encryption on non-compliant accounts. You start with audit, move to deny, use deploy if not exists as a safety net. The policy evolves as you learn what works. Why this skill is valuable is because designing policies that prevent problems without creating friction is harder than it sounds. A policy that's too strict blocks legitimate use cases. A policy that's too loose doesn't prevent erosion. The sweet spot requires understanding both the technical requirements and the organizational workflow. That's the skill that's rare. That's the skill that's valuable. This is where governance shifts from theater to reality. When policies are enforced through code, when violations are prevented before they reach production, when the system itself makes doing the right thing the path of least resistance, that's when erosion stops. That's when architects move from reacting to incidents to preventing them. Identity governance and intra-agent ID. Identity is the control plane for everything else in Azure. If identity is compromised, all downstream controls fail. This is why identity governance has to be airtight. And this is where most organizations are making catastrophic mistakes because they're still thinking about identity in human terms. Traditional identity governance focused on human users. Passwords, multi-factor authentication, conditional access policies, these are important, but they're only half the problem. The new reality is that non-human identities now outnumber human identities in most enterprises. Service principals, managed identities, AI agents, these aren't people. They don't need passwords. They don't need MFA in the traditional sense. They need something completely different. They need least privilege by default. They need just-in-time elevation. They need immutable audit trails. Here's what most organizations are doing wrong. They're sharing credentials between humans and AI agents. A team needs an AI agent to perform some task. Instead of creating a distinct service principal with scoped permissions, they give the agent a human's credentials. Or they create a single service principal and share it across multiple agents. Or they store credentials in plaintext in configuration files. These aren't security oversights, these are architectural failures. And they're creating massive vulnerabilities at scale. Entra Agent ID is Microsoft's answer to this problem. It's a framework that gives AI agents distinct identities with scoped permissions, audit trails, and lifecycle management. Each agent gets a unique service principal. Each service principal gets specific permissions for specific resources. Elevated operations require explicit justification. Every action gets logged in a way that cannot be modified after the fact. Here's how this works in practice. An organization registers an AI agent in Entra ID. The agent gets a unique object ID and app ID. The organization assigns the agent to a group. They apply policies to that group, conditional access rules, permission boundaries, approval workflows. When the agent needs to perform an action, it requests a token. The token is issued with scoped permissions. The action is logged. If the agent behaves unexpectedly, it can be disabled immediately without affecting other agents or human users. The architecture that works at this layer has several components. Every agent gets registered in your identity system. Agents are assigned to groups based on their function. Policies are applied to agent groups, not individual agents. An agent that handles customer data might be in a different group than an agent that handles internal operations. Each group gets different permissions. Agents can be disabled, rotated, or revoked without touching human credentials. Every agent action is auditable. Why this prevents erosion is straightforward. Without formal agent identity governance, teams resort to sharing credentials. Shared credentials are unauditable. You can't tell which agent took which action. You can't revoke an agent's permissions without revoking permissions for every other agent or human using that credential. You can't implement least privilege because the credential is shared across multiple entities with different needs. The system becomes impossible to govern. The cost of not doing this is staggering. A single compromised agent credential can exfiltrate data, modify systems, or trigger cost explosions without anyone knowing who did it. An agent with overprivileged permissions can perform actions that violate your compliance requirements. An agent that can't be disabled independently can force you to rotate credentials that affect dozens of other systems. The pattern that scales is elegant. Once you've designed identity governance for agents, you can apply it to new agents, new teams, new regions without starting over. You're not creating governance from scratch for each agent. You're instantiating a template that's already been tested and proven. An organization with a mature agent identity framework can onboard a new agent in hours. An organization without one spends weeks trying to figure out how to give the agent the permissions it needs without creating security vulnerabilities. The uncomfortable truth is this: most organizations don't have formal agent identity governance yet. They're running their AI infrastructure on shared credentials, which means they're operating in a state where a single misconfigured agent or compromised credential can cause exponential damage. They're treating agent identity as an afterthought instead of a first-class architectural concern, and they're about to discover how expensive that decision is. Cost governance and FinOps automation. Cost governance is governance that most organizations ignore until they get a bill that makes them panic. They treat cost as a finance problem instead of an architecture problem. It's not. Cost is a governance problem, and if you don't architect for cost control, you will discover very quickly how expensive it is to not have cost control. Here's the pattern. Teams experiment with AI. Agents run retry loops. Compute scales up. Suddenly you're paying 10 times more than expected. Nobody knows why. Nobody can explain it. The bill just keeps growing. This isn't a failure of the finance team. This is a failure of architecture. FinOps, financial operations for cloud, treats cost as a first-class governance concern, not an afterthought. The architecture that works includes cost allocation through tagging. Every resource tagged with cost center owner project. Budget controls at the subscription and resource group level with spending limits. Automated remediation that scales down underutilized resources, terminates orphaned assets, stops runaway processes. Forecasting and anomaly detection that predict spend and alert when deviations occur. The AI-specific problem is acute. Agents can generate massive costs through retry loops. An agent that retries a failed operation 1,000 times costs 1,000 times more than an agent that retries 10 times. Without cost controls, a single misconfigured agent can bankrupt a project in minutes. Not through malice, not through compromise, just through the normal operation of an agent operating at machine speed with unbounded retry logic. The pattern that prevents erosion is pre-execution cost estimation. Before an agent executes an operation, it estimates the cost. If the cost exceeds a threshold, the operation is blocked. The agent is routed to cheaper infrastructure. The operation is deferred. Cost controls become architectural constraints, not post hoc reviews. Here's what this looks like in practice. Define cost classes, gold, silver, bronze, based on acceptable spending per agent or workload. Implement pre-execution cost estimation. Block operations that exceed thresholds. Monitor actual spend against forecasts. Alert on anomalies. A spike in costs that indicates misconfiguration triggers an immediate investigation. You don't wait for the monthly bill, you catch it in real time. Why this skill is valuable is because designing cost governance that prevents explosions without stifling innovation is harder than it sounds. A cost control that's too strict blocks legitimate use cases. A cost control that's too loose doesn't prevent erosion. The sweet spot requires understanding both the technical requirements and the business model. That's the skill that's rare. Real scenario. An AI agent configured to search through 10 years of logs to answer a question. Without cost controls, the query runs for hours, costs thousands of dollars, and doesn't even provide useful results. With cost controls, the query is blocked or routed to cheaper infrastructure. The agent learns that expensive queries aren't allowed. It adapts its behavior. Cost governance becomes invisible because the system enforces it automatically. The scaling pattern is elegant. Once you've designed cost governance for one workload, you can apply it to new workloads, new teams, new regions without reinventing. You're not creating cost controls from scratch for each new agent. You're instantiating a template that's already been tested and proven. This is where most organizations fail. They treat cost as something to be managed reactively through better budgeting or stricter reviews. They don't treat cost as an architectural concern. They don't design systems where cost control is built in from the start. And then they get surprised when a single misconfigured agent generates thousands of dollars in unexpected charges. The organizations that understand this, that are building cost governance into their architecture, that are implementing pre-execution gates, that are treating cost as a first-class architectural concern, those organizations are going to win in 2026. Everyone else is going to have bills they can't explain and incidents they don't understand. CI/CD governance pipelines and shift-left security. Traditional security works like this. You build something, you deploy it to production, you find the problems, you fix them. This is reactive security. It's expensive, it's slow. It's the reason organizations are constantly dealing with incidents they didn't see coming. Shift-left security does something different. It prevents problems before they reach production, when they're cheap to fix, when they're still in code. When the developer who made the mistake is still thinking about the problem instead of 3 sprints ahead on something else. CI/CD governance pipelines are the mechanism that implements shift-left security. Here's how it works. A developer commits code to Git. A pipeline runs automatically. The pipeline validates the code against your governance policies. It checks compliance, it estimates costs, it scans for vulnerabilities, it validates against your security baselines. The pipeline either passes or fails. If it passes, the code can be deployed. If it fails, the deployment is blocked. The developer sees the error immediately. They understand why their code violated the governance framework. They fix it, they push the corrected code, the pipeline runs again. This time it passes. This is where governance becomes invisible. Developers don't have to think about whether their code complies with policies. The system tells them immediately if it doesn't. They fix it right away instead of discovering the problem 6 months later during a compliance audit. The policy is applied consistently to every deployment. There are no exceptions. There are no manual reviews. There are no workarounds. The governance gates that matter include policy compliance checks. Does this infrastructure comply with our policies? Cost estimation. Will this infrastructure cost more than expected? Security scanning. Are there known vulnerabilities in this code? Compliance validation. Does this infrastructure meet our regulatory requirements? These gates run in parallel. They run fast. They provide immediate feedback. A developer knows within seconds whether their code is compliant or not. Why this skill is valuable is because designing pipelines that enforce governance without creating friction is harder than it sounds. A pipeline that's too strict blocks legitimate use cases and slows down development. A pipeline that's too loose doesn't prevent erosion. The sweet spot requires understanding both the technical requirements and the development workflow. The anti-pattern is governance pipelines that are so strict they slow down development. This creates incentives for teams to bypass the pipeline. They find workarounds, they deploy directly to infrastructure, they skip the approval process. Bypassed pipelines are worse than no pipelines at all because now you have the overhead of a governance system that nobody's using. The pattern that scales is governance pipelines that are clear, fast, and fair. Clear means teams understand why policies exist and what they're trying to prevent. Fast means pipelines run in seconds, not minutes. Fair means policies apply equally to all teams. No special exceptions for high-priority projects. No shortcuts for senior engineers. The system treats everyone the same. Real scenario. A pipeline that validates Azure policy compliance before deployment. A developer writes bicep code that creates a storage account without encryption. The pipeline runs policy validation. The policy check fails. The developer sees the error immediately. They enable encryption in their code and resubmit. The pipeline passes. The code is deployed. This takes minutes. The developer learns the policy. They understand what's required. They move on. Without this gate, non-compliant infrastructure reaches production and becomes harder to fix. You discover the problem later. You have to remediate in production. You have to explain the compliance violation to auditors. You have to figure out how it happened in the first place. All of this is expensive. All of it is preventable through shift-left security. The scaling problem is straightforward. As teams grow, manual compliance review becomes impossible. You cannot have a person review every deployment. You cannot have a security team approve every change. Automated pipelines are the only way to enforce governance at scale. They run the same checks for every deployment. They apply the same rules to every team. They provide consistent enforcement without human bottlenecks. This is where governance moves from manual process to automated enforcement. When policies are validated in CI/CD pipelines, when violations are prevented before they reach production, when the system itself makes doing the right thing the path of least resistance, that's when erosion stops. That's when architects move from reacting to incidents to preventing them at the source. Drift detection and continuous compliance. Drift is the gap between intended state and actual state. You define how your infrastructure should be configured. You deploy it. For a while, it matches your definition. Then something changes. A manual modification, an automatic update, a misconfigured resource, a permission that got assigned and never removed. Slowly, the actual state diverges from the intended state. That's drift. And if you're not detecting it continuously, it's accumulating silently while you're not paying attention. Sources of drift are varied. Manual changes made through the portal instead of through code. Someone needs to troubleshoot an issue, so they modify a configuration directly in the Azure console. They're planning to update the code later. They never do. Now your actual infrastructure doesn't match your IAC definition. Automatic updates applied by Azure. Microsoft patches a security vulnerability. Azure applies the patch automatically. Your infrastructure is now more secure, but it doesn't match your code anymore. Misconfigured resources that don't match policy. A resource was created before the policy was deployed, so it never got validated. Now it violates the policy, but it's still running. Abandoned resources that are no longer used but still incur costs. A project ended 6 months ago. The infrastructure is still running. Nobody remembers to clean it up. Why drift matters is this. Every unit of drift is a unit of governance failure. You intended one thing, you got something else. That gap is a signal that your architecture isn't enforcing what should happen. It's a signal that something is broken. And if you're not detecting it, it's compounding. The pattern that detects drift is straightforward. Define intended state in code. This is your IAC, Bicep, Terraform, whatever you're using. This is your source of truth. Periodically scan actual state. Run a tool that looks at what's actually deployed in Azure. Compare intended versus actual. Look for divergence. Alert on divergence. Automatically remediate or require manual approval depending on the severity. The architecture that works at this layer includes infrastructure as code as the source of truth. Scheduled scans that compare code to actual resources. If you're not scanning regularly, you're not detecting drift. Alerts on divergence. Email, Slack, dashboard, however your organization communicates. Automated remediation for low-risk drift. If a tag is missing, add it. If a configuration drifted slightly, correct it. Manual approval for high-risk drift. If something changed in a way that might indicate a legitimate change, require a human to review it before reverting. Why this skill is valuable is because designing drift detection that catches real problems without creating alert fatigue is harder than it sounds. Too sensitive and you're alerting on every minor variation, you get alert fatigue. People stop paying attention. The signal disappears into noise. It's too insensitive and you're missing real drift. Resources diverge from intended state and nobody notices until an audit discovers the problem. Real scenario. A network security group is manually modified through the portal to allow SSH access for debugging. Drift detection finds the divergence. An alert is raised. The team reviews the change and decides whether it's intentional. If intentional, the change is committed to code. Now your ISC matches your actual infrastructure. If unintentional, the change is reverted, the resource is restored to its intended state. Either way, the gap between intended and actual is closed. The scaling pattern is elegant. Once you've designed drift detection for one workload, you can apply it to new workloads, new teams, new regions without starting over. You're not creating drift detection from scratch for each new application. You're instantiating a template that's already been tested and proven. The cost of not doing this is substantial. Drift accumulates silently. You have no idea what your actual infrastructure looks like. Resources diverge from policy without anyone noticing. Compliance violations go undetected until an audit. Security vulnerabilities are introduced through manual changes. Cost optimization opportunities are missed because you don't know what's actually running. By the time you realize drift is a problem, you've got months or years of accumulated divergence to remediate. This is where continuous compliance becomes real. When drift is detected automatically, when divergence triggers alerts, when the system continuously compares actual to intended and flags mismatches, that's when erosion stops. That's when architects move from hoping people follow the rules to ensuring the system enforces them automatically. Management groups and hierarchical governance. A management group is a container for subscriptions that allows you to apply policies, RBAC, and other controls hierarchically. This is the organizational structure that makes governance scale. Without it, you're managing governance at the subscription level, which means you're duplicating rules across every subscription. With it, you define rules once at a high level and they cascade down automatically. Here's why hierarchy matters. You have an organization with hundreds of subscriptions. You want to enforce a policy that says all resources must have encryption enabled. Without management groups, you have to apply that policy to every subscription individually. If you add a new subscription, you have to remember to apply the policy. If you want to update the policy, you have to update it in hundreds of places. This is not governance. This is chaos with extra steps. With management groups, you apply the policy once at the root level. Every subscription inherits it automatically. When you add a new subscription, it inherits the policy immediately. When you update the policy, the change propagates everywhere. This is governance that scales. The pattern that works has several levels. At the root management group, you define organization-wide policies, encryption requirements, logging requirements, compliance frameworks. These are non-negotiable. Every part of the organization inherits them. Below that, you have business unit management groups. Policies specific to that business unit. Maybe finance has different requirements than engineering. Maybe healthcare has different requirements than retail. Each business unit gets its own management group with policies tailored to its needs. Below that, you have environment management groups, production, staging, development. Each environment gets different policies. Production might require more stringent controls. Development might be more permissive to enable innovation. At the bottom, you have team management groups. Policies specific to that team's needs. Why this prevents erosion is that governance is inherited down the hierarchy. You don't have to redefine rules at every level. You don't have to manually apply the same policy to every subscription. The system enforces hierarchy automatically. A policy defined at the root applies to every subscription in the organization. A policy defined at the business unit level applies to every subscription in that business unit. A policy defined at the environment level applies to every subscription in that environment. The anti-pattern is a flat subscription structure with no management groups. This requires you to apply the same policies to every subscription manually. Policies are inconsistent across subscriptions. Some subscriptions have encryption enabled, others don't. Some subscriptions have logging configured, others don't. Governance becomes unmaintainable. You're constantly discovering that a policy exists in some subscriptions but not others. You're spending time on manual remediation instead of designing better governance. Real scenario. A policy that requires all resources to have a cost center tag. Root management group policy is defined once. All subscriptions inherit the policy. When the policy is updated, the change propagates to all subscriptions. When a new subscription is created, it automatically inherits the policy. No manual work required, no inconsistency, no exceptions. The policy applies everywhere because it's defined at the top and cascades down. Why this skill is valuable is because designing a management group hierarchy that scales to hundreds of subscriptions and teams is harder than it sounds. Too many levels and the hierarchy becomes unmaintainable. You've got so many layers that nobody understands how policies cascade. Too few levels and policies aren't granular enough. You're forced to apply organization-wide policies that don't fit every business unit's needs. The sweet spot requires understanding both the organization structure and the technical constraints of the system. The scaling problem is real. As organizations grow, management group hierarchies become complex. You start with a simple 3-level hierarchy, then you acquire another company. Now you need to integrate their subscriptions. Do you create a new branch in your hierarchy? Do you reorganize the existing structure? Do you create a separate hierarchy for the acquired company? These decisions compound. Before long, your hierarchy is a mess of special cases and exceptions. The pattern that scales is a hierarchy that's deep enough to be granular but shallow enough to be understandable. 4 or 5 levels is usually the sweet spot. Root for organization-wide policies. Business unit or geography for regional policies. Environment for dev, test, production, maybe one more level for specific applications or teams. Beyond that, you're creating complexity that doesn't add value. Why this matters is that a well-designed hierarchy prevents governance from becoming a bottleneck to innovation. Teams can operate within their branch of the hierarchy with autonomy. They inherit organization-wide policies that ensure security and compliance. But they also get policies tailored to their needs. This is where governance becomes an enabler instead of a blocker. Teams move faster because the system enforces what should happen automatically. They don't have to think about compliance. They don't have to request exceptions. The system is designed so that doing the right thing is the path of least resistance. This is the foundation that makes everything else work. Without a proper management group hierarchy, your policies are scattered. Your controls are inconsistent. Your governance is theater. With a proper hierarchy, governance scales automatically. Policies cascade down. Controls are consistent. The system enforces what should happen. Bicep and infrastructure as code patterns. Bicep is Microsoft's domain-specific language for defining Azure infrastructure as code. It's not the only option. You can use Terraform. You can use ARM templates. You can use CloudFormation if you're on AWS. But Bicep is what matters if you're building on Azure because it's designed specifically for Azure. It understands Azure resources natively. It integrates with Azure tooling seamlessly. And most importantly, it allows you to define infrastructure in a way that's readable, maintainable, and version controlled. Why Bicep matters in the context of governance is this. Infrastructure defined in Bicep is infrastructure that can be reviewed, tested, and enforced. When infrastructure is defined in code, you can run it through your governance pipelines. You can validate it against your policies before it's deployed. You can track changes through Git history. You can understand exactly who changed what and when. This is fundamentally different from infrastructure created through the portal or through ad hoc scripts. The pattern that works includes defining reusable modules, a storage account module, a virtual machine module, a network module. These modules encapsulate the complexity of creating a resource correctly. They enforce best practices. They ensure consistency. When a team needs a storage account, they don't create it from scratch. They use the storage account module. The module enforces encryption. The module enforces tagging. The module enforces logging. The team doesn't have to remember all these requirements. The module enforces them automatically. You compose modules into larger templates. A landing zone template that includes storage, networking, identity, and monitoring. An application template that includes compute, databases, and load balancing. These templates are versioned in Git, they're reviewed through pull requests, they're tested before deployment, they're deployed through pipelines that validate them against your governance policies. Why this prevents erosion is straightforward. Infrastructure defined in code is infrastructure that's repeatable. You deploy the same landing zone to 10 different teams and it's identical. You deploy an application template to 10 different regions and it's consistent. You're not relying on manual configuration. You're not relying on people remembering the right way to do things. The code enforces consistency automatically. The anti-pattern is infrastructure defined through the portal or through ad hoc scripts. Changes aren't reviewed. Changes aren't auditable. Changes aren't repeatable. You create a resource one way in one subscription and a different way in another subscription. By the time you realize the inconsistency, you've got technical debt spread across your entire environment. Real scenario. Defining a landing zone in Bicep. The template defines management groups, subscriptions, policy assignments, network configuration, identity configuration, monitoring infrastructure. When the template is deployed, the entire landing zone is created consistently. Every deployment of that template produces identical results. When the template is updated, all landing zones inherit the change. You're not manually updating 10 different landing zones. You update the template once and the change propagates everywhere. Why this skill is valuable is because designing Bicep templates that are reusable, maintainable, and enforce governance is harder than it sounds. A template that's too generic doesn't enforce governance. It's just a collection of resources without constraints. A template that's too specific can't be reused across different teams or regions. The sweet spot requires understanding both the technical requirements and the organizational needs. The scaling pattern is elegant. Once you've designed a landing zone template, you can deploy it to new business units, new regions, new teams without reinventing governance. You're not creating governance from scratch for each new deployment. You're instantiating a template that's already been tested and proven. The first landing zone takes weeks to design and deploy. The second one takes days. The third one takes hours. By the time you've deployed your 10th landing zone, you've got a repeatable process that works. The distinction that matters is this. Bicep templates that define infrastructure are useful, but Bicep templates that define infrastructure and enforce governance are valuable. A template that creates a storage account is nice. A template that creates a storage account with encryption enabled, with the right tags, with the right logging, with the right access controls, that's a template that scales. That's a template that prevents erosion. That's the skill that commands premium compensation in 2026. Conditional access and zero trust architecture. Conditional access is a policy engine that evaluates context and makes access decisions based on that context. location, device, risk level, time of day, anomalies. The system gathers signals about who's trying to access what and where they're trying to access it from. Then it makes a decision. Allow, block, require additional verification. This is fundamentally different from static RBAC assignments that never change. Why conditional access matters is this: it allows you to enforce zero trust principles at scale. Zero trust is a simple idea. Assume breach, verify every access request, grant least privilege, don't trust anything by default, verify everything continuously. Most organizations operate on the opposite principle. They assume their network is secure. They assume that if you're inside the network, you're trusted. They assume that once you've been granted access, you keep that access forever. These assumptions are wrong, and they're expensive. The pattern that works at this layer includes baseline policies, multi-factor authentication required, compliant device required. The system evaluates risk in real time, impossible travel, anomalous sign-in location, suspicious activity. If risk is high, the system blocks or requires additional verification. The system grants least privilege access, the minimum permissions needed for the task, not the maximum permissions the person might ever need, not the permissions they had in their last role, just the permissions they need right now for this specific task. Why this prevents erosion is that access is continuously evaluated and adjusted based on context. A user's permissions don't just stay the same forever. They change based on risk, based on location, based on behavior. If a user suddenly tries to access resources from a country they've never accessed from before, the system notices. If a user tries to access resources at 3 in the morning when they normally access them at 9 in the morning, the system notices. If a user suddenly tries to access resources they've never accessed before, the system notices. And the system responds. It might require additional verification. It might block the access entirely. It might grant temporary access with additional monitoring. The anti-pattern is static RBAC assignments that never change. A user is assigned the contributor role and keeps it forever. When the user's role changes, nobody remembers to update the assignment. The user has permissions they no longer need. The user leaves the company and their account is disabled, but the permissions are still assigned. The user's credentials are compromised and the attacker has access to everything the user had access to. None of this is prevented by static RBAC. Static RBAC is governance theater. It looks like you're controlling access, but you're not. Real scenario. A developer needs temporary access to a production database to troubleshoot an issue. Instead of assigning permanent contributor role, use conditional access to grant temporary access. 1 hour. Require MFA, require the request to be approved by a manager. Log the access for audit purposes. When the hour expires, access is revoked automatically. The developer can't access the database anymore. If they need access again, they have to request it again. This is least privilege. This is zero trust. This is how you prevent erosion. Why this skill is valuable is because designing conditional access policies that enforce zero trust without creating friction is harder than it sounds. A policy that's too strict blocks legitimate use cases. Users can't do their jobs. A policy that's too loose doesn't prevent erosion. Overprivileged identities persist. The sweet spot requires understanding both the security requirements and the operational workflow. The scaling pattern is elegant. Once you've designed conditional access policies for one scenario, you can apply them to new scenarios, new teams, new regions without starting over. You're not creating access controls from scratch for each new use case. You're instantiating a template that's already been tested and proven. An organization with mature conditional access policies can onboard a new user, grant them appropriate access, and revoke it when they leave, all without manual intervention. An organization without conditional access is constantly dealing with access requests, access reviews, and access cleanup. The cost of not doing this is substantial. Overprivileged identities are a leading cause of security breaches. Attackers compromise a single credential and suddenly have access to everything that credential had access to. If that credential had excessive permissions, the blast radius is enormous. Conditional access reduces that blast radius by ensuring that permissions are scoped to what's actually needed and continuously evaluated based on context. This is where governance moves from static rules to dynamic enforcement. When access is continuously evaluated, when risk triggers automatic responses, when the system adjusts permissions based on context, that's when erosion stops. That's when architects move from hoping people follow the rules to ensuring the system enforces them automatically based on real-time signals. Defender for Cloud and Compliance Automation. Defender for Cloud is Azure's security posture management service. It continuously scans your environment and alerts on misconfigurations, vulnerabilities, and compliance violations. It's not optional. If you're operating Azure without Defender for Cloud, you're operating blind. You have no visibility into whether your infrastructure is secure. You have no visibility into whether you're compliant. You're just hoping nothing goes wrong. Here's how it works. You enable Defender for Cloud on all your subscriptions. It immediately starts scanning your resources. It looks at your configurations It compares them against security benchmarks, Azure Security Benchmark, CIS controls, NIST, PCI DSS, whatever frameworks your organization cares about. It identifies violations, resources that don't match the benchmark, resources that violate compliance requirements, resources that have known vulnerabilities. It alerts you to every deviation. The pattern that works includes enabling Defender for Cloud on all subscriptions, not some subscriptions, all subscriptions. Configure security standards, choose the frameworks that matter to your organization. Monitor compliance against those standards, remediate violations automatically where possible, escalate violations that require manual review. This is where governance becomes continuous instead of episodic. Why Defender for Cloud matters is this. It detects problems continuously, not during annual audits. You discover a compliance violation the day it happens, not 6 months later when an auditor finds it. You discover a vulnerability the moment it's identified, not after an attacker exploits it. You discover a misconfiguration the instant it's deployed, not after it's been running in production for months. This is where governance moves from reactive to proactive. The distinction that matters is this. Defender for Cloud is detection. Azure policy is prevention. Defender finds problems after they exist. Azure policy prevents problems from being created. Together, they form a defense-in-depth approach. Azure policy stops non-compliant resources from being deployed in the first place. Defender for Cloud finds resources that somehow got deployed anyway. Maybe they were created before the policy existed. Maybe they were created through a manual process that bypassed the policy. Maybe they drifted after deployment. Defender catches all of these. The combination of prevention and detection is what creates real governance. Real scenario, a compliance requirement that all storage accounts must have encryption enabled. Azure policy prevents creation of non-encrypted storage accounts. Defender for Cloud detects existing non-encrypted storage accounts. Together, they ensure encryption is always enabled. Policy prevents new violations. Defender finds old violations. The organization gradually becomes compliant as old resources are remediated and new resources are prevented from being non-compliant. Why this skill is valuable is because designing compliance automation that works across your entire Azure environment is harder than it sounds. Defender for Cloud generates alerts, lots of alerts. If you don't have a process for handling those alerts, they become noise. You get alert fatigue, people stop paying attention. The signal disappears into the background. The skill is designing a system where alerts are meaningful, where violations are remediated, where compliance becomes automatic instead of manual. The scaling problem is real. Compliance requirements vary by team, by business unit, by region, by regulatory framework. You need a system that can handle this complexity without becoming unmaintainable. You need policies that are specific enough to catch real violations, but broad enough to apply across your organization. You need alerts that are actionable, not theoretical. You need remediation that's automated, not manual. The pattern that scales is governance frameworks that are composed of smaller, reusable pieces. A policy for encryption, a policy for tagging, a policy for logging. Combine these into a compliance standard, apply the standard to different scopes based on requirements. Different business units might have different standards, different regions might have different requirements, but the underlying policies are reusable. You're not creating compliance from scratch for each new team. You're combining existing policies into standards that fit the team's needs. Why this matters is that compliance automation is the only way to enforce governance at scale without hiring a compliance team. You cannot have a person review every resource in your environment. You cannot have a security team audit every configuration. Automated tools are the only way to enforce governance at scale. Defender for Cloud provides the visibility. Azure policy provides the prevention. Together, they create a system where compliance is enforced automatically, continuously, at scale. This is where governance moves from manual audit to continuous enforcement. When violations are detected automatically, when remediation is triggered by policy, when compliance is measured continuously instead of annually, that's when erosion stops. That's when organizations move from crossing their fingers and hoping for the best to ensuring the system enforces what should happen. The governance scorecard and measuring what matters. You can't improve what you don't measure. Most organizations measure the wrong things. They measure the number of policies they've deployed. They measure the number of deployments that happened. They measure uptime. These metrics don't tell you whether governance is actually working. They tell you that you have governance. They don't tell you whether it's preventing erosion. The metrics that matter for governance are different. They measure whether the system is actually doing what it's supposed to do. Policy compliance rate. What percentage of resources comply with policies? If you've deployed a policy that says all storage accounts must have encryption enabled and 80% of your storage accounts are encrypted, you have a compliance rate of 80%. That's not good enough. You should be targeting above 95%. The remaining resources are violations. They're either old resources that existed before the policy or they're new resources that somehow got created without the policy being enforced. Drift rate. What percentage of resources diverge from intended state? You defined how your infrastructure should be configured. You deployed it. Now you're comparing actual to intended. If 5% of your resources have drifted, that's a signal that your architecture isn't enforcing what should happen. You're not detecting drift quickly enough. or you're not remediating it, or you're not preventing it from happening in the first place. Your target should be below 5%. RBAC hygiene. What percentage of identities have least privilege access? This is harder to measure because least privilege is contextual. But you can measure it. How many users have the owner role when they only need reader? How many service principals have contributor permissions when they only need read access to specific resources? How many identities have permissions they're not using? If your RBAC hygiene is below 80%, you've got significant over-privileging. That's a security vulnerability. That's erosion.cost variance. How much does actual spend diverge from forecast? If you forecasted $10,000 a month and you spend $12,000, that's a 12% variance. That's acceptable. If you forecasted 10,000 and you spent 15,000, that's a 50% variance. That's a signal that something is wrong. Either your forecasting is broken or your cost controls aren't working. Either way, you need to fix it. Your target should be under 10% variance. Remediation time. How long does it take to fix a compliance violation? If a violation is discovered on Monday and fixed on Friday, that's 5 days of non-compliance. If a violation is discovered and fixed the same day, that's ideal. Your target should be under 24 hours. The faster you remediate, the less time your environment is non-compliant, the less time erosion is accumulating. The pattern that works is straightforward. Define target metrics. Policy compliance above 95%, drift rate below 5%. RBAC hygiene above 85%, cost variance under 10%, remediation time under 24 hours. Measure actual metrics. Run reports that tell you where you stand against these targets. Identify gaps. If your policy compliance is 85% and your target is 95%, you've got a gap. Design interventions to close gaps. Tighten policies. Remove exceptions. Improve enforcement. Measure again to verify improvement. Real scenario. A governance scorecard for a landing zone. Policy compliance is 92%, target is 95%, gap of 3%, drift rate is 8%, target is 5%, gap of 3%, RBAC hygiene is 78%, target is 85%, gap of 7%, cost variance is 12%, target is 10%, gap of 2%, remediation time is 36 hours. Target is 24 hours, gap of 12 hours. Now you have interventions. For policy compliance, tighten policies. Identify which policies are failing. Are they too broad? Are they catching legitimate use cases? Refine them. Remove exceptions. Exceptions are dead. For drift rate, improve drift detection. Maybe you're only scanning weekly, scan daily. Maybe you're not remediating automatically. Implement auto-remediation. For RBAC hygiene, implement just-in-time access. Remove permanent assignments. For cost variance, improve cost estimation. Maybe your forecasts are broken. For remediation time, automate remediation. Manual remediation is slow. Automated remediation is fast. Why this skill is valuable is because designing metrics that actually measure governance effectiveness is harder than it sounds. Easy metrics are meaningless. Hard metrics are hard to measure. The skill is finding the metrics that are meaningful and measurable. That's what separates governance that's real from governance that's theater. Scaling governance across teams and organizations. Governance that works for one team doesn't automatically work for 10 teams. As organizations scale, governance either becomes more systematic or it collapses. You can't scale governance through heroic effort. You can't scale it through a single person understanding all the rules. You can't scale it through manual processes that require human judgment at every step. Governance scales through automation and delegation, through frameworks that teams instantiate instead of creating from scratch, through policies that are enforced by the system instead of by people. Here's the pattern that works. You define governance principles, security, compliance, cost, agility. These are the things you care about. These are the things that matter to your organization. You codify these principles into policies, standards, and procedures, not as documentation, not as guidelines, as code, as enforcement mechanisms. You distribute governance responsibility. Teams own their own governance within frameworks. They're not asking for permission. They're not waiting for approval. They're operating within guardrails that the system enforces automatically. You audit and adjust continuously. Governance isn't static. Your organization changes, your requirements change, your threats change, your governance has to change with it. You measure compliance, you identify gaps, you adjust policies, you test changes, you deploy them, you measure again. This is a continuous cycle, not a one-time project. Why this prevents erosion is that governance scales through automation and delegation, not through centralized control. A central governance team that approves every change becomes a bottleneck. Teams wait for approval, teams get frustrated. Teams find workarounds. Teams bypass governance to move faster. Governance becomes a blocker instead of an enabler. The anti-pattern is a central governance team that controls everything. They own the policies. They approve every deployment. They review every change. They're the gatekeepers. This creates bottlenecks. It creates resentment. It creates incentives to bypass the system. Teams that feel blocked by governance don't comply with governance. They find ways around it. They use workarounds. They operate outside the framework. This is worse than no governance at all because now you have the overhead of a governance system that nobody's using. The pattern that scales is distributed governance with guardrails. Teams have autonomy within frameworks. They can innovate. They can move fast. but they're operating within constraints that ensure security and compliance. The constraints are enforced by the system, not by people. A team can't deploy non-compliant infrastructure because the system blocks it. A team can't exceed their budget because cost controls prevent it. A team can't create overprivileged identities because the system limits what's possible. The framework is enforced automatically. Teams don't have to ask for permission. They just operate within the constraints. Real scenario: a governance framework for AI agents. Principle: AI agents should have least privilege access. Policy: AI agents must be registered in Entra-Agent ID. Policy: AI agents must have scoped permissions. Policy: AI agent actions must be logged. Policy: AI agents must have human owners. Teams can create AI agents. They want to deploy new agents. They don't ask for permission. They follow the framework. They register the agent. They define scoped permissions. They assign a human owner. The system validates that the agent complies with policies. If it does, deployment proceeds automatically. If it doesn't, the system blocks it and tells the team what's wrong. The team fixes the issue and resubmits. No approval process, no bottleneck, no delay, just automated enforcement. Why this skill is valuable is because designing governance frameworks that scale to hundreds of teams without creating bottlenecks is harder than it sounds. You have to balance autonomy with control. You have to make constraints visible without making them burdensome. You have to enforce policies without blocking innovation. This is the skill that separates architects who understand scaling from architects who understand Azure. The scaling problem is real. As organizations grow, governance frameworks become complex. Too many policies and teams can't remember them all. Too few policies and governance isn't granular enough. You need frameworks that are simple at the core but extensible for specific needs. You need policies that are broadly applicable but allow for context-specific variations. You need guardrails that prevent the worst outcomes without preventing all outcomes. The pattern that scales is governance frameworks composed of smaller, reusable pieces. A core set of organization-wide policies that everyone follows, a set of business unit policies that apply to specific groups, a set of team policies that apply to specific workloads. Teams inherit policies from every level. They're constrained by all of them, but they're not overwhelmed by them. The constraints are layered. The system enforces them automatically. Teams operate within the constraints without thinking about them. Why this matters is that most organizations have governance frameworks that don't scale. They start with manual processes. They add policies as they grow. They patch problems reactively. By the time they realize governance isn't scaling, they've got technical debt spread across their entire environment. The organizations that understand this, that design governance for scale from the beginning, that build frameworks that are composable and extensible, that automate enforcement so teams don't have to think about compliance, those organizations are going to win in 2026. The career path. From infrastructure to governance architecture. The traditional career path in cloud has always been straightforward. Infrastructure engineer, you learn how to provision resources, you learn how to configure networks, you learn how to deploy applications, you move up to cloud architect. You design larger systems. You make decisions about how infrastructure should be organized. You move up to enterprise architect. You make decisions about how the entire organization should operate in the cloud. This path exists. It's well-defined. It's how most people think about cloud careers. There's a different path emerging, and it's the one that leads to higher compensation, more interesting problems, and genuine leverage over organizational outcomes. Infrastructure engineer, you learn how to provision resources. You learn how to configure networks. You learn how to deploy applications. Then you pivot. You become a governance engineer. You stop building new infrastructure and start designing the frameworks that prevent bad infrastructure from being built. You design policies, you design identity controls, you design cost governance, you design the systems that make doing the right thing the path of least resistance. You move up to governance architect. You design governance frameworks that scale across entire organizations. You design systems that prevent erosion at scale. You design the control planes that enable innovation without creating chaos. Why this path exists is because governance is becoming more valuable than infrastructure as organizations scale. When you're a startup with 10 engineers and 1 Azure subscription, infrastructure skills matter. You need people who can provision resources quickly. You need people who understand how to build systems. But when you're an enterprise with 1,000 engineers and 100 subscriptions, governance matters more. You need people who can prevent chaos. You need people who can enforce standards at scale. You need people who can design systems where compliance is automatic instead of manual. The skills that matter at each level are different. A governance engineer can design and implement governance frameworks for a single business unit or team. They understand Azure policy. They understand Bicep. They understand identity governance. They understand how to compose these into a framework that works for a specific context. A governance architect can design governance frameworks that scale across an entire organization. They understand how to make governance composable. They understand how to balance autonomy with control. They understand how to design systems that scale without becoming unwieldy. A principal governance architect can design governance frameworks that work across multiple organizations, multiple clouds, multiple regulatory frameworks. They understand how to make governance portable. They understand how to design systems that adapt to different contexts. Why compensation increases along this path is straightforward. Governance engineers are scarce. Most people want to build new things. They want to see their code running in production. They want to solve problems. Governance is about preventing problems. It's about making sure things don't go wrong. It's less glamorous. It's less visible. Most people don't want to do it. Most organizations don't have formal governance roles. The few organizations that do have formal governance roles understand the value. They pay premium salaries because they understand that a single governance engineer can prevent millions of dollars in incidents, compliance violations, and architectural debt. Real scenario: a governance engineer at a financial services company. Salary range $150,000 to $200,000. Responsibilities: design and implement governance frameworks for regulatory compliance. Prevent compliance violations that could cost millions in fines. Move to governance architect role. Potential salary: $200,000 to $300,000. Responsibilities: design governance frameworks that scale across multiple business units, prevent architectural erosion across the entire organization, enable innovation without creating chaos. This is where the compensation premium becomes substantial. Why this matters is this: if you're building a career in Azure, governance is a more valuable specialization than infrastructure. Infrastructure skills become obsolete as Azure services change, new services launch, old services are retired. The skills you learned 2 years ago might be irrelevant today. But governance skills compound. The governance framework you designed for one organization can be adapted for another. The policies you wrote can be reused. The patterns you learned scale across contexts. Your value increases as you accumulate experience with governance patterns. The market opportunity is substantial. There are hundreds of thousands of infrastructure engineers. There are tens of thousands of cloud architects. There are thousands of governance engineers. The supply is tiny compared to demand. Organizations are desperately looking for people who can design governance frameworks that scale. They're looking for people who understand how to prevent erosion. They're looking for people who can make governance invisible because it's so well designed that teams don't even think about it. How to transition is straightforward. Start by designing governance for your current team. Design the policies, design the controls, design the frameworks, expand to larger scopes as you gain experience. Design governance for your business unit. Design governance for your organization. Build a portfolio of governance frameworks you've designed. Document the outcomes. Show the metrics, show the compliance rates, show the cost savings, show the incidents prevented. This is how you build credibility as a governance architect. This is how you move from infrastructure to governance. This is how you position yourself for the high-income roles that are going to dominate in 2026. Building your governance foundation. The first 90 days. If you're starting from scratch, here's the order to tackle governance. Not all at once, not in parallel, in sequence. Month 1, establish identity governance. Month 2, establish policy governance. Month 3, establish operational governance. This is the order that works because each layer builds on the previous one. Month 1 is identity governance. You start here because everything else depends on it. You can't enforce policies without knowing who's doing what. You can't audit actions without knowing who performed them. You can't prevent erosion without controlling who has access to what. So you start with identity. Audit existing identities. Who has what access? This is harder than it sounds. You're not just looking at human users. You're looking at service principals, managed identities, application registrations, every non-human identity that has access to your resources. Most organizations discover they have far more identities than they thought. Service principals created for automation that nobody remembers. Managed identities assigned to applications years ago. Application registrations for integrations that no longer exist. You're going to find a lot of cruft. Identify overprivileged identities. Who has more access than they need? A user with the owner role who only reads resources. A service principal with contributor permissions that only needs read access to specific storage accounts. A managed identity with broad permissions when it should have scoped permissions. You're going to find a lot of overprivileging. This is where most organizations are. They grant broad permissions to get something working quickly. They plan to tighten it later. They never do. Implement least privilege access, remove unnecessary permissions. This is the hard part. You have to understand what each identity actually needs, not what they might need, not what they had before, what they actually need right now. You have to be ruthless about removing permissions. If an identity hasn't used a permission in 90 days, it probably doesn't need it. Remove it. If an identity has permissions to resources it doesn't interact with, remove them. If an identity has broad permissions when scoped permissions would work, scope them. Implement conditional access policies, enforce multi-factor authentication, require device compliance, block access from suspicious locations. This is where you move from static access controls to dynamic ones. Access is no longer just a binary decision. It's evaluated based on context. Risk, location, device, time of day. The system adjusts access based on these signals. Implement just-in-time access. temporary elevation for privileged operations. A user needs to perform an administrative task. They request temporary access. The system grants it for a limited time. 1 hour, 2 hours, whatever the task requires. When the time expires, access is revoked automatically. The user can't access the resource anymore. This is where you prevent standing privileges from becoming permanent vulnerabilities. Month 2 is policy governance. Now that you have identity controls in place, you can enforce policies. Define governance principles. What are you trying to prevent? Unencrypted data, untagged resources, resources in unauthorized regions, resources without logging. Define your principles clearly. These are non-negotiable design policy framework. What policies enforce your principles? A policy that requires encryption on storage accounts. A policy that requires tagging on all resources. A policy that restricts deployment to authorized regions. A policy that requires logging on all resources. Start with a small number of core policies. You can add more later. Implement policies in audit mode. Deploy your policies, but don't enforce them yet. Just detect violations. Run this for a week or two. See what violations you find. Some violations are going to be legitimate. Resources that existed before the policy. Resources that need exceptions. Some violations are going to be mistakes. Resources that were misconfigured. Resources that shouldn't exist. Identify which is which. Test policies. Identify false positives. A policy that catches legitimate use cases. Refine the policy. Make it more specific. Make it less likely to catch false positives. Identify false negatives. A policy that should catch something but doesn't. Refine the policy. Make it broader. Make it catch what it's supposed to catch. Shift to deny mode. Now enforce the policies. Block non-compliant deployments. This is where governance becomes real. Teams can't deploy resources that violate policy. They have to fix their deployments. They have to comply. Month 3 is operational governance. Now that you have identity controls and policies in place, you can enforce governance operationally. Design CI/CD pipelines. Enforce governance before deployment. Implement drift detection. Catch divergence from intended state. Implement monitoring and alerting. Visibility into governance metrics. Implement remediation. Automatically fix violations where possible. This is a 90-day sprint. By the end, you have governance foundations in place, identity is controlled, policies are enforced, operations are governed. You're not done. Governance is never done. But you've established the foundations. You've prevented the worst outcomes. You've created the frameworks that scale. From here, you expand. You add more policies. You extend governance to new teams. You refine controls based on what you've learned. But the foundations are solid. The counterintuitive truth about governance. Governance is often seen as a blocker to innovation. It's the thing that slows you down. It's the reason you can't move fast. It's the bureaucracy that prevents you from getting things done. This perception is wrong, and it's expensive to be wrong about this. The counterintuitive truth is this: governance is an accelerator to innovation, not a blocker, an accelerator. The best-run organizations move faster than poorly governed organizations. They innovate more, they ship more, they achieve more. The difference isn't that they have fewer constraints. It's that they have the right constraints, constraints that prevent the worst outcomes without preventing all outcomes. Here's why. A team without governance moves fast initially. They provision resources quickly, they deploy applications, they ship features, they're moving at full velocity. Then they make mistakes, misconfigurations, security gaps, cost overruns. They discover problems in production. They spend time fixing mistakes. They spend time in incident response. They spend time remediating compliance violations. They slow down. By the end of the quarter, they've shipped fewer features than a team with governance because they spend so much time fixing problems. A team with governance moves slightly slower initially. They have to think about compliance. They have to follow policies. They have to tag resources. They have to request approvals. But they make fewer mistakes. They spend less time fixing problems. They spend less time in incident response. They spend less time remediating violations. By the end of the quarter, they've shipped more features because they didn't waste time fixing preventable problems. The distinction that matters is this: governance that's designed well accelerates innovation. Governance that's designed poorly blocks it. Most organizations have governance that's designed poorly. That's why they see it as a blocker. They've implemented governance in a way that creates friction without creating value. They've implemented governance in a way that requires manual approval for every change. They've implemented governance in a way that's so strict it forces teams to find workarounds. The pattern that works is governance that's clear, fast, and fair. Clear means teams understand why policies exist and what they're trying to prevent. If a team understands that encryption is required because unencrypted data creates compliance violations, they're more likely to comply than if they're just told encryption is required. Fast means policies are enforced automatically, not through manual approval processes. A developer commits code. A pipeline validates it. The validation takes seconds. The developer knows immediately whether their code is compliant. If it's not, they fix it. If it is, it deploys. No waiting for approval. No bottleneck. Fair means policies apply equally to all teams. No special exceptions for high priority projects. No shortcuts for senior engineers. The system treats everyone the same. Real scenario: a company with a policy that requires all resources to be tagged. Poorly designed, governance team reviews every deployment and requires tags before approval. This is slow, this is manual, this creates a bottleneck. Teams wait for approval, teams get frustrated. Teams find ways to bypass the system. Well designed. policy automatically blocks untagged resources. Developers tag resources in their code. The policy validates the tags. If tags are present and correct, deployment proceeds automatically. If tags are missing or incorrect, the policy blocks deployment and tells the developer what's wrong. The developer fixes it. No approval process, no bottleneck, no delay. Just automated enforcement. The difference is that the well-designed governance system makes compliance the path of least resistance. Developers don't have to ask for permission. They don't have to wait for approval. They just follow the constraints that the system enforces. And because the constraints are clear and reasonable, they don't feel like a burden. They feel like guidance. They feel like the system is helping them do the right thing instead of blocking them from doing it. Why this skill is valuable is because designing governance that accelerates innovation instead of blocking it is harder than it sounds. It requires understanding both the technical requirements and the human factors. It requires understanding what constraints are actually necessary and what constraints are just bureaucracy. It requires designing systems where doing the right thing is easier than doing the wrong thing. This is the skill that separates governance architects from people who just implement policies. The market opportunity is this. Organizations are desperate for people who can design governance that works, not governance that's theater, not governance that creates the illusion of control without preventing erosion, governance that actually prevents problems while enabling innovation. Organizations that get this right move faster than their competitors. They ship more, they innovate more, they win. Organizations that get it wrong are constantly dealing with incidents and erosion. They lose. The people who understand this, who can design governance that accelerates instead of blocks, those people are going to be in very high demand in 2026. The skill that matters in 2026 isn't knowing Azure services. It's architecting governance frameworks that prevent erosion at scale. This is the skill that commands premium compensation. This is the skill that creates genuine leverage over organizational outcomes. This is the skill that separates the architects who understand cloud from the architects who just know how to click buttons. If you're building a career in Azure, governance is the specialization that compounds. The frameworks you design scale. The patterns you learn transfer. The value you create increases as you accumulate experience. Start with identity. Move to policy. Expand to operations. Build governance that's clear, fast, and fair. Build governance that accelerates innovation. Build governance that prevents erosion. That's the skill that matters in 2026.